Good morning, everyone. Welcome to Software Engineering. I'm Zhang Shuang from Software College, Northeastern University. Today, we are going to learn Introduction to Object, Data Encapsulation. Actually, in previous sections, we have learned quite a lot about the object-oriented paradigm. Actually, we should understand the object-oriented paradigm from the concept of modules. And we have got to know that the criteria to design modules should achieve high coherence and low coupling. Right? Okay. So next point is data encapsulation related to object-oriented paradigm. Let's take an example first. Suppose we are to design an operating system for a large mainframe computer. It has been decided that batch jobs submitted to the computer will be classified as high priority, medium priority, or low priority. There must be 3 queues for incoming batch jobs, 1 for each job type. When a job is submitted by a user, the job is added to the appropriate queue, and when the operating system decides that a job is ready to be run, it is removed from its queue and the memory is allocated to it. Well, okay, so surely this is a quite common problem for all operating systems. So now let's suppose we are going to design this operating system. So what will you do? Maybe someone will design in this way. He thinks surely there will be functions such as initializing job queue. Okay, so this M1. And another function adding job to queue. So this is our M2. And remove job from queue. So we call it module M3. Okay. So let's think about it. Do you think it's a good design or not? So let's assume that maybe the data structure or the implementation of job queue are supposed to change. What will happen? So maybe now the job queue's data structure is linear link, and now we are going to change it to other data structures. And surely the functions of initialize job queue, add job to queue, and removing job from queue will change. Right? So that means 3 modules will be affected. So we must admit that this is not a good design. Let's have a look at another design. Okay. 1, 2, 3. We can see that in this module, there are 3 functions or methods: initialize job queue, add job to queue, and remove job from queue. Okay. And all of the methods or functions operate on the same data structure, job queue. So that means the implementation of job queue or the data will affect only 1 module rather than 3 modules. Okay, so everyone will admit that the second design is better. So with such a design of M123, okay, surely we'll get a data structure like this, okay, or a module. In this module, we got 3 functions or 3 methods. And each method has its own entry and its own exist and also its own implementation. They are quite independent to some degree, but of course, they are within the same module and they operate on the same data structure, job queue, and they share the implementation of the job queue, right? Okay. So we can see that the data and the operations that operate on the data structure is encapsulated in the same module. So this is object-oriented paradigm implementation of module. And we know that from the point of view of coherence, it is informational coherent, right? Like the highest coherent. Okay? And actually, it can also be called encapsulation. because the data and the operation operating on the data is encapsulated in the same module. So we can give such a conclusion about the design of the example. M encapsulation has informational coherence, and M encapsulation has the implementation of data encapsulation, that is a data structure, together with the operations to be performed on that data structure. Well, so maybe someone will ask why, right? So let's discuss about the advantage of data encapsulation. When we talk about the software system, we should think about both the development and the maintenance, right? So now let's discuss the advantages of data encapsulation from the viewpoint of development and the maintenance. Okay, first, data encapsulation and development. Data encapsulation is an example of abstraction. So let's take the example of job queue again. Just now we have said that job queue is data structure. And there are three operations. Okay? Initialize job queue, add job to queue, and delete job from queue. Okay? Well, this module is a kind of abstraction. So we can understand in this way that an abstraction of a module is the data structure and the operations operating on the data structure. So that is data abstraction. Data abstraction allows the designer to think at the level of data structure and the operations performed on it, and only later be concerned about the details of how the data structure and the operations are implemented. Right? Okay, so that means to make things easier, to make design easier. So the designers doesn't need to consider so many things altogether. So he can consider things level by level. So this is the advantage of encapsulation for design, for implementation. Okay, next, data encapsulation and maintenance. Approaching data encapsulation from the viewpoint of maintenance, a basic issue is to identify the aspects of a product likely to change and design the product to minimize the effect of future changes. So that means data encapsulation makes maintenance easier. So let's take the example, job queue. So this is Java code for job queue. So the class name is job queue class, and some attributes, job queue. The queue here is defined as an array, and another attribute is the length of the queue. And the three methods, initialize job queue, and add job to queue, and remove job from queue. So we can see that everything is just within this class. And from the point of view of outside the class, the other class don't need to know the change or modify of this class. All that they can access is just the interface of the methods, such as the initialize job queue, add job to queue, or remove job from queue. Right? So this is the advantage of data encapsulation. And the system will invoke class that doesn't have any knowledge as to how the job queue is implemented. The only information needed to use job queue class is interface information regarding the three methods, just like what we have discussed just now. So data encapsulation supports the implementation of data structure in a way that simplifies maintenance and reduces the change or regression falls. So these are the advantages of data encapsulation for both implementation and maintenance. So much for this point. Thank you.